All right, question 1. Solve the following simultaneous equations. So we got this thing here and this thing here. All right, I'm going to start by rearranging equation 1 to get y is equal to 3 upon 2x. And I'm going to try to substitute that into equation 2. But before I do that, I'm going to rearrange equation 2. So that will give me y to the power of 4 is equal to 27 upon 16, x to the power of 5. So now I can substitute in for y here. So that's going to give me 3 upon 2 x to the power of 4 is equal to 27 upon 16 x to the power of 5. And if I was to expand on the left-hand side, I've got 3 to the power of 4 divided by 2 to the power of 4 times by x to the power of 4 is equal to, now on the right-hand side, I think I can simplify that, right? Because 27 is 3 to the power of 3 and 16 is 2 to the power of 4. Okay, so now if I was to multiply both sides by 2 to the power of 4, right, those are going to cancel off. And I can divide both sides by 3 to the power of 3, right? So if I've got 3 to the power of 4 and I divide by 3 to the power of 3, then I'm left with 3 to the power of 1. And if I divide both sides by x to the power of 4, right, divide by x to the power of 4 on both sides, on the right-hand side, I'm going to get x to the power of 1. The indices rules you'll remember is a to the power of x divided by a to the power of y is equal to a to the power of x minus y, right? I subtract the powers. So that's basically what I've done there. Okay, so we've got x is equal to 3. And if x is equal to 3, we can find out what y is. We just substitute in y is equal to 3 upon 2 times by 3, which is equal to 9 upon 2. Okay, so I get the two answers there. For x is equal to 3 and y is equal to 9 upon 2. Okay, question 2. The variables x and y are related by this equation here. Y is equal to x times by the square root of 1 plus 2x. Find dy dx. Well, the important thing to notice about this is that we've got a product rule. Why? Because we've got the product of two functions, okay? We have got a function here and we've got a function here, right? So I'm going to call the first one u and I'm going to call the second one there v. Right, so whenever we've got the product of two functions, that means two functions multiplied together, we need to use the product rule. And what is the product rule? The product rule is y prime, right, dy dx is equal to v du dx plus u dv dx, right, v du plus u dv. So what I'm going to do is I'm going to write down what u is, that's equal to x, and I'm going to write down what v is, that is 1 plus 2x to the power of a half. So now if I differentiate u, right, then that's going to give me 1. If I differentiate v, this is going to be a chain rule. Why is it a chain rule? Because I've got one function, which is 1 plus 2x, inside another function, which is the x to the power of a half. So how do I differentiate this? Well, I differentiate the big bracket, right? So take the power, bring it down to the front, and I subtract 1 from the power, right? So if I just reiterate that, take that, bring it down to the front, subtract 1. And then after that, I look at the function on the inside, the 1 plus 2x, and I differentiate that. That gives me 2, and I multiply through by 2. And of course, that means, therefore, that the half and the 2 cancel off. So I'm just left with that. Okay, so then I just need to substitute in. So y prime is equal to v times by du. So that's 1 plus 2x to the power of a half plus u times by dv, which is going to be x times by 1 plus 2x to the power of negative half. Now, we're not asked to simplify, I think, here, but I'm going to simplify it anyway. So what is the power of a half? Well, it's the square root, isn't it, right? So this is the square root of 1 plus 2x. And what's the power of negative a half? Well, the negative means we've got a reciprocal, so that's 1 over the square root of 1 plus 2x. Okay? So in that particular power, the half means the square root and the negative means 1 divided by. Okay, now how do I combine these two terms? It's like adding fractions. I can think of the term on the left as the square root of 1 plus 2x over 1. So if I want to add up two fractions, I need to give them a common denominator. And so what am I going to do? Well, I'm going to multiply the top and the bottom of this by the square root of 1 plus 2x. So if I do that, I'm going to get the square root of 1 plus 2x times by the square root of 1 plus 2x all over the square root of 1 plus 2x. plus x over the square root of 1 plus 2x. Okay, now then, if we think about the top here, I've got the root of 1 plus 2x times by the root of 1 plus 2x. In other words, I've got the root of 1 plus 2x squared. So what I'm going to be left with is 1 plus 2x. Okay, and then I've got the other term here, this guy here, the x, and this is all going to be over the square root of 1 plus 2x. Now, if you're not sure about that, what I've just done, let me just make that very clear to you. If I've got the square root of a, and I times it by the square root of a, what that actually means is I've got the square root of a squared, right? So I root a number and then I square it. Well, that's going to give me back to a, isn't it? If you think about it, let's say a was 100, right? If I square root it, I'll get 10. And if I square it, I get back to 100, right? If a was 36, if I square root it, I get 6. And if I square it again, I get back to 36, right? If a was 9, right? I square root it, I get 3, and I square it, I get back to 9, right? So if we square a square root, right, then we get back to our original value. Okay, so now if I just simplify the top, I've got 1 plus 3x over the square root of 1 plus 2x, and that should be our final answer. Now, I'm not sure what the mark scheme says. It may be that you didn't have to simplify it. I mean, it didn't ask to simplify it, but I think it's a good practice to do that. Yeah. Actually, so the mark scheme says you don't have to simplify it, but I think it is good practice. So I've done that for you as well. All right, let's go to the next one. It is given that when y is equal to 12, x is equal to 4, find the approximate change in x when y increases from 12 by the small amount of 0.06. Okay, this is this type of question. So delta y is approximately equal to dy dx, okay, times by delta x. And the clue for that is this is an approximate change, okay? So if it's an approximate change, we're using this thing. Now, what does this represent? Let's very briefly revisit the theory. So let's imagine that we've got a function, okay? So our function may look, oh, sorry about that. Our function may look something like this. I don't know. We like that, okay? And yeah, let's say that we've got the values that we're given in the question. So when x is 4, let's say that y is equal to 12, right? So it's that point there. And we want to find the approximate change in x when y increases from 12 by the small amount of 0.06. So we imagine that we go up, right, a little bit to 12.06, okay? So we would be going to that point there on the curve, okay? And what we want to find is the corresponding change in x, right? So if I was to sort of draw this out, this thing here would be our change in x, and this thing here would be our change in y, right? So we would typically label that and say, okay, that's delta x, small little change in x, and this is delta y, the small little change in y. Well, okay, well now let's imagine that what we did is we took the gradient of the tangent at this point here, and I'm going to make that into a green line. Okay, like that. Okay, now hopefully what you can see is that the gradient of this tangent, which is given by dy dx, is basically going to be approximately the same thing as the gradient of this little triangle thing here, which is delta y divided by delta x, right? So if I was asked to find the gradient between those 2 points, then that gradient would be delta y divided by delta x. And that's very, very similar to the gradient of the tangent here. So basically what we end up saying is, okay, delta y divided by delta x, right? The gradient between the 2 points is roughly the same thing as the gradient of the tangent, dy dx, so long as like delta x or delta y is very, very small, right? So long as the 2 points are really close together, then we can use the approximation. Okay, so that's the idea. So basically, we're interested in whatever the gradient is when x is equal to 4. So we're just going to go back to here, and we can say, all right, when x is equal to 4, then dy dx, right, is going to be equal to 1 plus 3 times 4, which is 12, over the square root of 1 plus 2 times by 4, which is 8. So we end up getting here 1 plus 12 is 13, and 1 plus 9 is, 1 plus 8 is 9, square root is 3. So we get the gradient of the tangent there is 13 upon 3. So we can say, all right, delta y upon delta x is approximately going to be equal to 13 upon 3. What is my delta y? Well, my delta y is 0.06, isn't it, right? Because it's the increase in the y value. So I can write there 0.06 divided by delta x. And delta x is the thing that I want to find. So I can then just rearrange this and say, okay, delta x is approximately going to be equal to 0.06 times by 3 upon 13. Okay, and so that will be approximately equal to, well, I'll write it as, this is 6 upon 100, isn't it? Times by 3 upon 13. So that's approximately equal to 18 upon 1300. And that's going to be approximately equal to 9 over 650. Okay, so that's the answer that I get. Let me just check the mark scheme, make sure that I'm all correct. Yeah, 9 upon 650 or an equivalent, they allow the decimal there, is totally fine. All right, let's do the next one. Find the x-coordinate of the stationary point on the curve. Okay, well, where do we get a stationary point? A stationary point is when dy dx is equal to 0. Okay, so when dy dx is equal to 0. What does it actually look like? Well, let's draw a cubic, I guess. So we got something like, oh, yeah. Let's draw something like that. Okay, a stationary point would be at this point, or at this point, and these are what we call like local maxima or local minima, and the gradient there is 0 and 0. If you think about it, because as we're going up to the maximum point, the gradient is positive, 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 and then after it's going to be negative, 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 isn't it? So as we go from positive to negative, the gradient here had to be 0. Same thing for the minimum, right? It was negative, negative, negative gradient, and then it will become a positive, positive gradient, which means that in the middle, it's got to be 0. So basically, we just got to take our dy dx and set it equal to 0. So we'll just go back again. So what did we have? We had 1 plus 3x over the square root of 1 plus 2x. Okay, so y prime is equal to 1 plus 3x over the square root of 1 plus 2x. So we set that equal to 0. So 0 is equal to 1 plus 3x over the square root of 1 plus 2x. If I times both sides of the equation by square root 1 plus 2x, I get 0 is equal to 1 plus 3x. Okay, so 3x is equal to negative 1, which means that x is equal to negative a third. Okay, so that's the x-coordinate. Am I asked to find the y-coordinate? I'm not asked to find the y-coordinate, but if we were, then we would just substitute it in, right? So y would be equal to negative a third, the square root of, what is it? 1 plus 2 times negative a third. So 1 plus negative 2/3, isn't it? And 1 minus 2/3 is a third. So we get negative 1 upon 3, the square root of 1 upon 3. Okay, and we probably would have to rationalize that. That'd be negative 1 upon 3 root 3. So if I multiply top and bottom by root 3, I would get negative root 3 upon 3 root 3 times root 3, which is 3 times 3. So that would be negative root 3 upon 9. Okay, so I just done that just in case, you know, sometimes the question asks you to find the coordinates, right? So it'd be good practice. Let me just check that the answer is negative a third, and I think should be okay. Where am I looking? Yeah, negative a third or equivalent. Okay, question 3. The polynomial is defined by p of x is equal to ax cubed minus 3x squared minus 3x plus b, where a and b are constants. Given that x is equal to 2 and x is equal to negative 1 are roots of the equation, find a and b. Well, what is a root? A root is where the function is equal to 0, right? So a root is where the function is equal to 0. So for example, if x equals a is a root, what it means that f of a will be equal to 0. In other words, we can substitute the value into the polynomial and what we should get is 0. So if we are told in the question that 2 and negative 1 are roots, what it means is that if I was to substitute 2 into the polynomial, I should get 0. If I substitute -1 into the polynomial, I should also get 0. So that's exactly what I'm going to do, right? So p of 2 should be equal to 0. So let's do that. So we're going to get a times by 2 cubed, so that's 8a, minus 3 times by 2 squared. Well, 2 squared is 4 times by 3, 12 there. Minus 3 times by 2, so that's minus 6, plus b is equal to 0. So that's going to give 8a plus b is equal to 18. And then if I do the same for -1, so substitute -1 into the polynomial. So a times by -1 cubed, so that's negative a, minus 3 times by -1 squared is -3. Minus 3 times -1 is positive 3, plus b is equal to 0. And so that means that a is going to equal to b. Well, okay, if a is equal to b, I've got two equations, two unknowns, so I just substitute into the first one. So 8a plus a is equal to 18. So that means that 9a is equal to 18. So a is equal to 2. And if a is equal to 2, it therefore follows that b is also equal to 2. Right, so that's the solution for that. Okay, solve the equation p of x is equal to 0. Well, let's just write it out in full now. So ax cubed, so 2x cubed, minus 3x squared minus 3x plus b, minus 3x plus 2. Okay, so we want to solve that. Well, I think probably the easiest way that we can do is to use the factor theorem. And the factor theorem is as follows, right? If x equals a is a root, then it follows that x minus a is a factor. Right, so we know two roots, right? We are told that 2 is a root and -1 is a root, right? So since x equals 2 and x equals -1 are roots, that therefore means that x minus 2 is a factor, and x minus -1, which is x plus 1, is also a factor, right? So we've got the roots over here, and that means that we've got the factors that corresponds to those roots. Well then, if x minus 2 is a factor and x plus 1 is a factor, if I multiplied those two things together, I would also get another factor. So I multiply these two together, and that would give me x squared minus x minus 2. So what I'm trying to say is, if I know that x minus 2 is a factor and x plus 1 is a factor, this quadratic will also be a factor. Now, if you're not entirely sure about that, we can just imagine the corresponding idea with numbers, right? So let's say I've got a number like 30. Right, and I'll do the factor tree of that. So I get 5 and 6 and 2 and 3, right? Then what does it mean? If I was to tell you that a certain unknown number has got a factor of 2 and also a factor of 3, then that means I'm also telling you that it's got a factor of 6, right? Which is 2 times by 3. Okay, so if I know that a number has got a factor of 2 and 3, I also know that it must have a factor of 6. And the same thing is true with these polynomials, right? If I've got a factor of x minus 2 and also a factor of x plus 1, I must have a factor of those two things multiplied, which is this. Well, then, therefore, what I can do is I can find the remaining factor by doing polynomial division, right? So I'll do my polynomial division. So 2x cubed, what was it? Minus 3x squared. Minus 3x plus 2, was it? Yeah. And we're going to divide that whole thing through by the quadratic factor, which is x squared minus x minus 2. Okay, so how do we do polynomial division? We take the leading term 2x cubed and we're going to divide it by this term x squared. So 2x cubed divided by x squared is 2x. We then take that 2x, we multiply it through by the divisor. So that will give us here 2x cubed minus 2x squared minus 4x. Okay, and we're going to subtract one term from the other, 1 from the other. So 2x cubed minus 2x cubed is 0. Negative 3x squared minus 2x squared, so that's plus, right, is going to give us minus x squared here. Minus 3x minus 4x, so it's plus 4x. It's going to give me positive x there and plus 2 there. Okay, so next thing, I take the new leading term, negative x squared. I divide it by x squared. That gives me negative 1. I take the negative 1 and I multiply it through by the divisor. So that will give me negative x squared plus x plus 2. And as expected, if I subtract that off, I should get 0. Why is that expected? Well, because we said that this thing must be a factor, right? And if it is a factor, there will be a remainder of 0. So what have we just shown? We have basically shown that the polynomial can be factorized as x squared minus x minus 2 times by 2x minus 1. And of course, we knew that that quadratic term is equal to, was it x minus 2, x plus 1? Was that right? Yeah, x minus 2, x plus 1. Okay, and so therefore the solutions to p of x equals 0 is going to be x is equal to 2, x is equal to negative 1, and then x is equal to positive a half, right? Because if x minus 2 is a factor, 2 is a root. If x plus 1 is a factor, then negative 1 is a root. And if 2x minus 1 is a factor, that means a half is the root, okay? If you're confused about that, it's just because I set 2x minus 1 equal to 0, which solves to give x is equal to a half, okay? I hope that that was all clear. All right, then, question 4. Use a graphical method to solve the inequality mod 2x minus 8 is greater than 4. Now, a graphical method is basically the worst way to solve this, but never mind. They've asked us to do it. So what should we do? We basically want to plot the equation of y is equal to mod 2x minus 8. And how do we plot the graph of y equals mod 2x minus 8? The first thing we do is we plot the graph of y equals 2x minus 8 without the modulus. Okay, so y equals 2x minus 8. And hopefully you know that that is a straight line with a gradient of 2, and that goes through the y-intercept at negative 8, right? So we expect the graph here to go through negative 8, and gradient of 2, right? So it's going to go through the x-intercept at 4, but if you really weren't sure about that, x-intercept is when y is equal to 0. So we've got 0 is equal to 2x minus 8. So 2x is equal to 8, which means x is equal to 4. Okay, so the line would look something like that. Okay, so I'm just going to do that one more time, if you don't mind. Right, something like that. And so what's going to happen as we do the modulus of this? Well, the function of the modulus, right, is if the number inside the modulus is positive, there's no change, right? So for example, the modulus of positive 3 is just equal to 3. Whereas if we've got a negative value inside the modulus, then the function of the modulus is to turn it into a positive, right? So the modulus of negative 5 is equal to 5. So all of these values of the line y equals 2x minus 8, these are all positive, right? They're all positive y values, so those remain unchanged, right? Which is this guy here. But all of these values here, the y values are negative, right? So the values of 2x minus 8 are negative. So what's the modulus going to do? The modulus is going to make them into positives. And practically speaking, that looks like them being reflected in the x-axis. Okay, so it's going to be reflected like that, which means that it's going to have a y-intercept at positive 8 instead of at negative 8. Okay, so what I've just done there, this thing is the graph of y is equal to the modulus of 2x minus 8. Now then, we want to find out when this graph is greater than 4. So I'm going to draw the line y is equal to 4, which I think is like there. Yes, good enough. Y is equal to 4. And so what are we saying? Well, where is the graph greater than 4? Well, it's going to be this part of the graph, and it's going to be that part of the graph. Okay, and probably what you can do is you can just like read down. If you've got a reasonably accurate graph, you can read down there and go, okay, well, that looks like we've got 2. You can read down from here and go, okay, that looks like we've got 6. Okay, so you say, all right, fair enough. The graph tells me that if I want to be in this part of the graph, then my x values need to be greater than 6. Okay, so you say x is greater than 6. And if I want to be in this part of the graph, right, that part there, then my x values need to be less than 2. So x must be less than 2. But can we show that a little bit better using algebra just to confirm it for ourselves? We go, okay, well, this part of the graph, right, that guy there is just the same thing as the graph of y is equal to 2x minus 8, right? So y is equal to 2x minus 8 is that part of the graph on the right-hand side. And we're intersecting that with the line y is equal to 4. So basically what we're trying to find is when does 2x minus 8 equal 4? Okay, well, if we did that, we would get 2x is equal to 12, and therefore x is equal to 6. Okay, so that's great. So we've confirmed that intersection point there. So that means that this thing here is right. But what about for the other side? Well, the graph here, right, is the values of 2x minus 8, but we've made them into a positive. Now, how have we done that? We can imagine we've multiplied them by -1. Now, I'll just recap with you the idea of the modulus, right? I said before, the modulus of -5 is +5. So what's a way in which the modulus could turn it into a positive? Well, you can imagine we just multiply it by -1, right? So we get negative of -5 is equal to +5. So in the same way, right, if I had the graph of y equals 2x minus 8, and that value of 2x minus 8 was negative right down here, then if I multiply it by -1, then I'm going to turn it into a positive. Okay, so I can say that I've got the left-hand side of the graph is like negative of 2x minus 8, and I want to find out where that is equal to 4. So negative 2x plus 8 is equal to 4, which means that negative 2x is equal to -4, which means that x is equal to +2, which again is what we got from the graph. And so that's these two solutions here. Okay, so just doing it every way, and of course you could do it by squaring both sides as well. But I hope you get a kind of a full understanding there of what's going on. Okay, question 5, which is a logarithm question. We've got log base 2 of x squared plus log base 16 of x is equal to 18. Now, the first thing you should notice is we've got two different bases here. So if we've got two different bases, then we need to change it so that we've got the same base. That means we can either change log base 2 to log base 16, or we can change log base 16 to be base 2. And in general, you want to go from a high base to a low base. That's usually easier. Now, what's the formula for changing base? Well, if I've got log base a of x, and I want to convert it to be log base b of x, then we're going to divide through by log base b of the old base. Okay, and if you want a key to remember that is that on the right hand side, the two bases are the same, right? So base b, base b. So in this particular case, right, what am I trying to do? I'm trying to convert log base 16 of x into log base 2 of x, and that means I've got to divide through by log base 2 of the old base, which is 16. And what is log base 2 16? It's a quarter. It's 4, sorry. So I get log base 2x divided by 4. Now, why is that? Well, because what does the logarithm mean? It means what power do I have to give this base to in order to get 16? Well, what power do I have to give 2 to get 16? It's 4. 2 to the power 4 is equal to 16. Right? So that means that log base 2 16 is just equal to 4. Okay, so now that I've done that, I can substitute into our equation. So we are going to get log base 2 of x squared plus a quarter of log base 16, not log base 16, log base 2, because I've just done the conversion, x is equal to 18. Now I can do another rule with this guy here. I can take that power and bring it down to the front, right? Now, if you're not sure about that, we've got the following rule. If I've got log of a to the power of p, then that's equal to p times by log a, right? So I'm going to take that power of 2, I'm going to bring it down to the front as a coefficient. So that gives me 2 times by log base 2x plus a quarter times by log base 2x is equal to 18. And if you think about it on the left-hand side, right, I've got 2 lots of log base 2x plus a quarter lots of log base 2x. So how many lots of log base 2x do I have? Well, I've just got to add up 2 and a quarter, and that's going to give me 9 upon 4. Right, so I've got 9 upon 4 lots of log base 2x is equal to 18. So if I multiply through, right, log base 2x is going to be equal to 18 times by 4 upon 9. So I can cancel off and get 8 on the right-hand side. So log base 2x is equal to 8. So x is going to be equal to 2 to the power 8, which is 256. Okay, so that's the answer for part A. For the next part, part B, it's a little bit more tricky, but essentially what we need to do is we need to notice a trick. So I can rewrite this as e to 2x plus 1 minus 10 e to the negative 2x plus 1 is equal to 3. And then I can use a substitution. I can say let u equal e to the 2x plus 1. And if I do that, this becomes u minus 10u to the power negative 1 is equal to 3. Or if you prefer, u minus 10 divided by u is equal to 3. And so then if we multiply through, u squared minus 10 is equal to 3u, right? So I multiply everything through by u to get rid of this u on the denominator. Then I get u squared minus 3u minus 10 is equal to 0, and that is a quadratic which we can solve. And if we solve that, we get u minus 5, u plus 2. So there are two solutions, right? U is either equal to negative 2 or u is equal to positive 5. But what was u equal to? It was equal to e to the power 2x plus 1. Right? So e to the power 2x plus 1 can either equal to negative 2 or 5. Now, hang on. This is not possible, right? Because there's no value that we can make this power that will give a negative here. So that's not possible. So we're just left with the thing on the right. So we need to then simplify this using natural logs, right? So 2x plus 1 will be equal to the natural log of 5. So 2x is equal to the natural log of 5 minus 1. So x is equal to a half of the natural log of 5 minus 1. Okay, and that should be our answer. And I'm just going to check that against the mark scheme to see if everything is correct. Yep, that is exactly right. Okay, then question 6, which is a surds question. We want to write 5 minus root 3 times by root 6 plus root 2 to the power of negative 2 in this form here. So I think we should start by simplifying this. This means 5 minus root 3 over root 6 plus root 2 squared, right? That's what the power of negative 2 means. And I think we want to deal with that denominator first. We want to expand that first and simplify it before we do anything else. So I'm going to say we're going to do root 6 plus root 2 squared, which is root 6 plus root 2 times by root 6 plus root 2. So we do it nice and slowly. So we get root 6 times by root 6, which is 6. And we've got root 6 times by root 2, which is root 12. And we've got root 2 times by root 6, which is root 12. And we've got root 2 times root 2, which is 2. So if we were to simplify this, we end up with 8 plus 2 lots of root 12. Now we can simplify the root 12 because root 12 can be written as the root of 4 times by 3. And the root of 4 is 2, right? So we've got 8 plus 2 times 2 lots of root 3. So we've got 8 plus 4 root 3. So we've got the denominator there. So we've got 5 minus root 3. 5 minus root 3 divided by this thing, which is 8 plus 4 root 3. And what I suggest you do is you try to simplify early and often. Right, we want to keep the numbers small. So that means that I am going to factorize out the 4 on the denominator to get 2 plus root 3. Okay, so now that I've done that, I want to rationalize this denominator. And if I want to rationalize the denominator, it means I've got to multiply top and bottom by the conjugate, which in this case is 2 minus root 3. Right, so if you're not sure what the conjugate is, right, you look at the denominator. If you've got 2 plus root 3, the conjugate will be 2 minus root 3. Okay, so we switch the plus with the minus. And why do we do that? Well, because when we end up multiplying these two terms out, the square roots are going to cross out and disappear. Okay, so if we multiply out the top, we get 5 times by 2, which is 10. 5 times by minus root 3 is minus 5 root 3. Minus root 3 times by 2 is plus, not plus, sorry, is minus 2 root 3. And minus root 3 times by minus root 3 is positive 3, right? Minus times minus is positive, and root 3 times root 3 is 3. All over, let's expand the bottom. We got 4. 2 times by 2 is 4. Minus 2 root 3 plus 2 root 3, so those cancel off, right? So minus 2 root 3 plus 2 root 3. And then minus root 3 times root 3 is minus 3. So those cancel off, that and that. And 4 minus 3 is 1. So what we end up with on the top is we got 10 plus 3 is 13, minus 7 root 3 over 4 times by 1. Okay, and we want to leave it in the form a plus b root 3. So we'll write it as 13 upon 4, that's our a, minus 7 upon 4 root 3, and that's our b. And I'm just going to check that against the mark scheme. And yep, that is correct. Okay, then here we are in question 7, a combinations permutations style of question. Class of 10 students includes Abby and Ben. A group of 5 students is to be selected from the class. Find the number of possible groups. In the following cases, there are no restrictions. Okay, in this case, we are choosing 5 students out of 10 students. So that is just a case of 10C5. Okay, so we can stick that into a calculator and we'll get our answer. Why are we using combinations and not permutations? You need to understand the distinction. Combination is we are choosing 5 items from 10, whereas permutations would be arranging 5 items out of 10. Okay, so what's the difference between choosing and arranging? Choosing, the order does not matter. If we are arranging something, then the order matters. Okay, so in this particular case, because we just want a group of students, right? We don't care about the order in which we select them. Then all we're going to do is we're going to choose. So order doesn't matter, so we use combinations. Okay, so 10C5, I don't know what that is actually. I don't have my calculator. The mark scheme says that's 252. Okay, 252. We could probably calculate it though. Let's say we didn't have our calculator or our calculator stopped working. It's a good mental habit to try to do that. So 10C5, what does that actually mean? It means 10 factorial over 5 factorial times 5 factorial. Which is a formula that's given to you on the front of the exam. So 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3. So we can cancel off one of the 5 factorials with the top. Okay, so what can I do with this? Well, I can cancel off, can't I? I don't know. What should I cancel off? 4 times 2 cancels off the 8. Cancel off the 3 with that, which gives me a 2 there. Cancel off a 5 there. That gives me 2 there. So what am I going to get? This is going to be 2 times 9 times 7 times 2. Okay, 9 times 7 is 63. So we've got to times it by 4. So 63 times by 4. If I double it, I'm going to get 126. And if I double it again, I'm going to get 252. Okay, so that is the right answer, same as in the mark scheme. Okay, never mind. Good to be able to do it both ways, yeah? Okay, the group includes both Abby and Ben. Okay, well, if it includes Abby and Ben, right, then I've only got to select 3 remaining students. And how many students can I select them from? Well, I've got 10 to start with, and I can't choose Abby and Ben because they've already chosen. So that's going to be 8C3. Okay, so 8C3, and hey, we can do it exactly the same way again. Let's do 8C3. Okay, 8C3 is equal to 8 factorial over 3 factorial 5 factorial. So that's going to be 8 times 7 times 6, right? Because the 5 factorial cancels out there. Over 3 times 2 times 1. Okay, well, 3 times 2 cancels off there with the 6. And so we've got 8 times 7, which I think is 56. So I think the answer to that is going to be 56. And I will check that against the mark scheme again, just make sure that things are going all right. Yeah, 56, that's okay. Okay, part 3, the group includes either Abby or Ben, but not both. Okay, so let's say we had Abby, but not Ben. Okay, How many ways could we do that? Well, we've got one student in the group in the group, which is Abby. So we need to select 4 remaining students. How many students can we choose them from? Well, we started with 10. We've already chosen Abby, and we can't have Ben. So actually, we've only got 8 students left remaining to choose from. So that's going to be 8C4, right? We're selecting 4 students out of 8. And the same thing is going to be true with Ben, but not Abby. Okay, same thing, 8C4. So there are 2 ways that we can have it. So the final answer is just going to be adding up both of these. Well, again, let's do 8C4. Just for the sake of completeness, 8C4 is 8 factorial over 4 factorial times by 4 factorial. So it's going to be 8 times 7 times 6 times 5, because the 4 factorial cancels off, times 4 times 3 times 2. All right, I don't know, we could do 4 times 3, cancels off. 4 times, not 4 times 3, beg your pardon. 4 times 2 cancels off with the 8, and then we can divide by 3, so that becomes a 2. So we end up with 7 times 2 times 5. Well, 2 times 5 is 10, so that's going to be 70. So we've got over here 70 plus 70, which is going to be equal to 140. Okay, so that is 140 on the mark scheme. Yeah, so that's all correct. Okay, let's go to part B. Have we got the second part of the question here? Hang on, let me try to put that in. Okay, so this is part B. All 10 students are arranged in a line. How many arrangements are possible if there are exactly 3 students between Abby and Ben? Okay, well, I think it's generally better if we just draw this out. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so what situations can we have? Well, let's say if we've got Abby here, then we want 1, 2, 3 spaces in between. So Ben would have to be there. So how many ways can we do this? Well, we could try to work it out, right? So we could start with Abby here, or we could have Abby here, or we could have Abby here, or we could have Abby here, right? And every time we move Abby, we're also moving up Ben. And so kind of the last arrangement will be here. That will be Ben there, and Abby will be over here, right? Okay, do you understand that? So if Ben's there, Abby must have been there. So how many ways are there of arranging this kind of unit? We've got 1, 2, 3, 4, 5, 6, right? So there are 6 ways of kind of arranging Abby and Ben relative to each other. And of course, we could reorder them, right? We could start with Ben first instead of Abby. So we've gone to times by 2. And then we've got to think to ourselves, well, okay, well, how many other of these students are we going to arrange? Well, we've put 2 in place, and there are 8 left over, right? So it's going to be times by 8 factorial. So I think the answer there is going to be 6 times 2 times 8 factorial. I used the calculator on my laptop. So let's find 8 factorial. Okay, and I got to times it by 12, isn't it? Oh, do that again. 8 factorial, yeah, times by 12. And that gives me 483,840. So 483,840. 483,840, and I will just check that against the mark scheme, because I think it's a little bit tricky, that one. 483,840. Yeah, that's correct. Okay. Is there another way that we can think about this? Yes. So again, let's try to draw out the diagram. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's imagine that, you know, we had Abby here, we had Ben there. Okay, so we kind of got a group here, right? So that's going to be a unit where we've got Abby at the beginning, Ben at the end, and we've got 3 students in the middle. Well, how many ways can we arrange those 3 students in the middle? Well, I'm going to say we've got 8 students to choose from, so that's going to be 8p3 ways of choosing those students in the middle. And then how many ways can we sort of arrange everything else? Well, we've got 1 unit here, 2 units. This now thing is all considered as 1 unit, so that's 3, 4, 5, 6. So we're going to times through by 6 factorial. So times through by 6 factorial. And of course, I forgot we can have Abby and Ben in 2 different arrangements, right? Either have Ben here instead of Abby and so on. So I think we can have 2 times 8p3 times by 6 factorial. And let me just try to figure out what that would be. So 8p3 is 8 factorial over 5 factorial times by 6 factorial. And that is going to work out as being 2 times by 8 factorial times by 6, isn't it? Because 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 5 factorial is 5 times 4 times 3 times 2 times 1. So everything cancels out apart from the 6. So we end up again with 12 times by 8 factorial, which is what we had before. Okay, so let me just reiterate what I've done there. I've basically said, okay, I'm going to choose this kind of unit of 5 people first. So how many ways going to do that? Well, I've got Abby and Ben at both ends. So there are 2 ways I could arrange them. And then I want to have 3 people in the middle. How many ways can I arrange those 3? Well, I've got 8 people to choose from, selecting 3, so that's 8p3. Okay, then. So along with that single unit now, I've got 1, 2, 3, 4, 5 others to arrange. So I've got 6 things to arrange in total. So I multiply through by 6 factorial. Okay, I think that's actually quite hard, really. I mean, you know, those questions can be very difficult, and I think it's probably one of the harder that I've seen. So well done if you've been able to do that. But I hope the explanation I've given is also clear and helpful. Okay, so here we are in question 8. We want to solve the equation cot squared of 2 theta plus 3 cosec 2 theta is equal to 9. And I think the best way we want to do this is by using an identity to begin with. So the identities are given in the front of your exam paper, and you are told that cosec squared x is equal to 1 plus cot squared x. Okay, so we can use that. We can replace this cot squared with a cosec squared minus 1. So that's what I'm going to do. I'm going to say here we've got cosec squared of 2 theta minus 1 plus 3 cosec 2 theta is equal to 9. Okay, and this is going to be a quadratic, and I think the way to make that clear is to use a substitution. Let u equal cosec squared 2 theta. So we're going to get u squared minus 1 plus 3u is equal to 9. And that's going to give us u squared plus 3u minus 10 is equal to 0. And this is going to factorize to give u plus 5 and u minus 2. And we know that because we're looking for 2 numbers that multiply together to give negative 10 and that add up to give positive 3. And therefore that means that u is either equal to negative 5 or u is equal to positive 2. And of course, u is equal to cosec of 2 theta. So cosec 2 theta is equal to negative 5, and cosec 2 theta is equal to positive 2. Let me just change that. 2 theta is equal to positive 2. Now, what is cosec? We always look at the third letter, right? So the third letter is s. So cosec is 1 divided by sine. So 1 divided by sine 2 theta is equal to negative 5, which means that sine 2 theta is equal to 1 divided by negative 5, or negative a fifth. And similarly over here, sine 2 theta is equal to a half. Okay, so what we're trying to do now is we're trying to solve these 2 equations. Now, I do this different ways on different questions, right? I either use the graph of the sine or the cosine or whatever, or I use the unit circle. I think in this case, I'm going to use the unit circle just for a bit of variety, and it's helpful for you to know different ways in which you can solve things. So what's the unit circle? Unit circle is a circle of radius 1, right? That's what the word unit means. Unit just means 1. It's the same way you think about the unit vector, right? Unit vector is a vector of size 1. Okay, so here is the unit circle. And I want you to imagine that what we have is we've got a point somewhere on this circle. Let's do that again, right here. Okay, and so here's our point, and that makes an angle of theta with the x-axis. The distance from this point to the center is going to be 1. And critically, right, if this has got an x-coordinate here of x and a y-coordinate of y, what's x going to be equal to? Well, x is going to be equal to cosine of theta, right? Because, right, we think about it as adjacent over hypotenuse. So the adjacent is the x, the hypotenuse is 1, right? So adjacent over hypotenuse is equal to x. And of course, for a triangle, adjacent over hypotenuse is cos theta. another way of thinking that through, by the way. Sorry, it's probably not super clear what I've just done. But what I'm saying is, imagine that we've got a point, and the point has got coordinates x and y, right? If I was to change the angle of theta so as to drag this point all the way around the circle, then what's going to happen is the coordinates of x and y are going to change, right? So if I start here where the angle is 0, the x coordinate is going to be 1, the y coordinate is 0. If I bring the point around to here where the angle is 90 degrees, the x coordinate is 0 and the y coordinate is 1, and so on and so on. What does this mean? It means that the x coordinate is a function of the angle, and the y coordinate is also a function of the angle. It's a different function. Now, what do we call those two functions? Well, for x, we call it the cosine, right? And for y, we call it the sine. So in other words, actually, what are sine and cosine? They're not really about triangles. What they're telling us is they're telling us the x and the y coordinates on this unit circle. That's the big idea. So when I say what is like cosine of 30, it means if I find the angle of 30 degrees, let's say here, cosine of 30 is going to tell me the x coordinate of this point. In the same way, if I say what's sine 180, right? Well, I find the angle of 180 and I say, okay, well, what's the y coordinate? And the y coordinate is 0. Okay, so cosine and sine, what they're doing is they are telling us the x and y coordinates on the unit circle. That's the big idea. So if what we've got here is we're trying to solve, for example, sine 2 theta is equal to half, we're really asking, where is the place on the unit circle where the y coordinate is equal to a half, right? Because sine is the y coordinate. So where is the y coordinate equal to a half? Well, let's just draw a line where y is equal to a half. And we can see we're going to get 2 points, right? We're going to have this point here, but we're also going to have this point over here, right? So I could equally draw this angle. Right, so what is this angle here? Well, that angle is going to be 30 degrees, okay? Because sine inverse of a half is 30 degrees. So we can say here, okay, 2 theta is equal to 30 degrees. But it could also be equal to this angle here, right? That big angle there. Well, this angle here is going to be 30 degrees because of symmetry, right? That's the same as that. So this angle is going to be 180 minus 30. Why is that? Because we've got 180 over here. Minus 30 takes us back to there. So we got 150. And therefore, if we were to divide both sides by 2, then what we're going to get is we're going to get 15 degrees and we're going to get 75 degrees. Okay, so we get the two solutions there. All right, so what about this guy? Sine 2 theta is equal to negative a fifth. So we're trying to find out the y coordinate, where the y coordinate is equal to negative a fifth, right? So we could do that over here, right? So this is where y is equal to positive half. This is where y is equal to negative a fifth. And we can see that we're going to have two solutions to that. We're going to have this angle here, and we're going to have that angle there. Okay, so what's the angle that takes me to here? Well, if I put that into my calculator, I get negative 11.54. Okay, so 2 theta equal to 11.54, or rather negative 11.54 because I'm going back. And then what would be this angle here? Well, by symmetry again, right, that angle has got to be the same as this one. So this angle here is 11.54. So this angle is like going to be minus 180, and then we've got to go back 11.54, right? So you can think of it as minus 180 plus 11.54 if you prefer. And that's going to give me negative 168.46. Now, if I was then to divide both sides by 2, then what I'm going to get is negative 5.77. So I'll round it up to negative 5.8. And if I was to divide the other one by 2, I get negative 84.23. So I round it down, negative 84.2 degrees. Okay, so I end up there with 4 solutions. And I'll just check the mark scheme. And yeah, that looks good. Okay. Okay then, question 9. A particle is moving in a straight line with constant velocity of 6. At time t is equal to 0, it passes a fixed point A. At time t is equal to 5, it suddenly changes direction and moves with a different constant velocity along the same straight line. It passes the point A again at time t is equal to 15. Sketch the velocity time graph. Okay, well, there's essentially a key fact to know about this. And I would say it's this, that the area under a velocity time graph equals the displacement. Okay, that's the key thing. And you kind of know that because displacement is equal to the integral of velocity with respect to time. And when we integrate, we're finding the area underneath the curve. So in effect, what do we know? We know that this particle is moving with a constant velocity of 6 for the first 5 seconds. So it's going to look like that. Okay. And then what displacement has it covered in that time? Well, it's going to be the area of this shape here, right? Which is 6 times 5, which is 30, right? So the displacement there is 30. So in the remaining 10 seconds, right, from 5 to 15, we also want it to have a displacement of negative 30 because it's going to be going back to where it started. So if the base of this is going to be 10, then we require that the height of the rectangle is going to be 3. So therefore, this has got to be negative 3 here, from there to there. Okay? So that value there is going to be negative 3. So let me just try to just explain that one more time. Essentially, we know that because the particle passes the point A again at time t is equal to 15, it means that we're back to the same point, which means in the end, the displacement is going to be 0. So whatever displacement we have in the first 5 seconds has got to be undone by the displacement in the subsequent 10 seconds. And since displacement is the area underneath the velocity time graph, whatever that area is must be equal to this area here, right? So if this is 30, that must also be 30. And therefore, because it's a constant velocity, this must be negative 3, because negative 3 times by 10 is equal to 30. Okay, so let's move on to part B then. So we have another particle is moving in a straight line with a constant acceleration. Okay, so constant acceleration, right? So this is different to constant velocity. Constant acceleration means we're going to have a straight line graph that's going to look something like that. Okay. At time t equals 0, it passes a fixed point B with a velocity of negative 8, and it passes the point B again at time t is equal to 20. Sketch the velocity time graph for this motion. Okay, so let's say negative 8 is here. Right, so there's negative 8. So again, it's basically going to be the same principle as before, right? The area between the underneath the velocity time graph is going to be equal to displacement. So if we know that we're going to be passing the point B again, it means that our net displacement's got to be 0. That means that the area under, right? Let's draw it like that, whatever. The area under this part of the graph would have to be equal to the area under that part of the graph, right? Because this is like a negative displacement, and this is going to be a positive displacement here. So when are these two areas going to be the same? Well, if they're going to be equal, right, then we're going to have to cut through at this point here at 10. So if we're going to do that, it's going to look something like that. And this must here be a velocity, therefore, of positive 8. Okay, like that. Because that is the only way that we're going to be able to guarantee having equal areas for this and for this. Now, if you're not too happy about that and you feel like I've kind of tricked you a little bit, then I think we can work it through a little bit more slowly using an alternative method. So we can say that, okay, displacement, right, S is equal to ut plus a half at squared. So the initial velocity is negative 8. So we've got negative 8t plus a half at squared. And we know that this displacement is going to be 0 at 2 points, right? So S will be equal to 0 when t is equal to 0 and when t is equal to 20. Now, when t is equal to 0, that's kind of obvious, right? Because 0 there plus 0 there is just going to be equal to 0. So that's kind of obvious. But we can substitute in when t is equal to 20. So we get 0 is equal to negative 8 times by 20 plus a half of a times by 20 squared. So let's try to think that one through. So that's going to be negative 160. So 20 squared is 400 divided by 2 is 200. Okay. And so therefore, A is going to equal to 160 divided by 200. And that's going to be 16 upon 20. I can divide top and bottom by 4, so I think it's going to be 4/5. Okay, so A is equal to 4/5 meters per second squared. Okay, well, if that's going to be the case, right, what's our velocity going to be when t is equal to 20? Right, well, we can say v is equal to u plus at. Okay, our initial velocity is -8. Our acceleration, as we just said, is 4 times 5. And our time that we're interested in is 20 seconds. Okay, so that's going to be equal to -8 plus 16, which is equal to +8. So in other words, we can say, okay, well, we know that our when t is equal to 20, our velocity's got to be equal to +8. Okay, so we know this point and we know this point. We know it's a constant acceleration, so we just draw a straight line going between them. Okay, so if you really weren't satisfied with kind of the argument just considering the areas under the graph, which I think is okay, then you can do it the long-handed way by using the kinematics equations. I hope that was helpful. I think it's a little bit tricky, that question. But yeah, I think if you kind of just think about it in that particular way, it should be okay. Okay, then question 10, the diagram shows part of the curve y is equal to x minus x squared upon 4, and the line y is equal to -4, which is that one. The curve and the line intersect at the point A. Find the maximum value on the curve is at a perpendicular distance of h from the line y is equal to -4. Find the value of the h. Okay, so we want to find this height here. Okay, so basically we want to find the maximum point. I mean, there are so many ways we could do that. We could like find the roots of the quadratic, right? And then the maximum point's going to be halfway in between. We could complete the square of the quadratic. I'm going to differentiate it. I mean, just got to choose one way, right? So if y is equal to x minus a quarter x squared, then if I differentiate that to get y prime, I get 1 minus a half x, right? Just to clarify that, I bring the 2 down to the front. So 2 times a quarter is a half, and I subtract 1 from the power, which gives me x to the power 1. Okay, a maximum point is a stationary point, and that's when y prime is equal to 0. So 0 is equal to 1 minus a half x. And if I rearrange that, a half x is equal to 1, so x is going to be equal to 2. So the x coordinate is 2. So what's the y coordinate going to be? I just substitute in, right? So I get 2 minus 2 squared, which is 4 upon 4. And so I get 2 minus 1, which is 1, right? So the y coordinate of this is 1. So let me just label it on, right? So the x coordinate is 2. The y coordinate there is 1. Okay, so what's the distance going to be? Well, it's going to be 1 plus the 4, right? Because the distance from here to here is 4. So the total height is going to be equal to 5, right? H is going to be equal to 5. Should we just try to do it another way as well, just to show that we could have done it? So we'll find the x-intercepts of this. So x-intercepts where y is equal to 0. So x-intercept is when y is equal to 0. So 0 is equal to x minus a quarter x squared. Okay, so we factorize that. So we get x bracket 1 minus a quarter x. So that gives us two solutions, right? Either x is equal to 0 or 1 minus quarter x is equal to 0, which means that x is equal to 4. Okay, so we got our two roots, right? We got a root here when x is 0 at the origin. We've got a root here at 4. So where's the maximum going to be? Well, it's going to be the midpoint of those two, which is obviously x is equal to 2, and then we can find the y coordinate by substituting in again. Okay, so there are a couple of ways that you could do this. B, find the exact x coordinates of A. Well, what is it? It's the A is the intersection, isn't it, of the curve with the line y equals -4. So we just got to solve simultaneous equations. So x minus a quarter x squared is equal to -4. So 0 is equal to a quarter x squared minus x minus 4. I think I'll times everything through by 4. So I get x squared minus 4x minus 16. Now that is a quadratic that isn't going to factorize, so I'm going to have to use the quadratic formula. So x is equal to minus b, so it's going to be minus minus 4, plus or minus the square root of b squared, so we've got -4 squared, minus 4 times a, which is 1, times c, which is -16. All over 2a, so 2 times 1, Okay, so let's simplify this. So we're going to get minus minus 4, which is plus 4, plus or minus the square root of, okay, so we got 16 here. Minus minus is a plus, so we got plus 4 times 16. So I'm going to keep it like that just for the moment. Why is that? Well, because I can factorize out 16. So I get 4 plus or minus the square root of 16 bracket 1 plus 4. Thank you. See that? Because if I factorize out 16 from here and here, factorize out from here, I get 1. Factorize from here, I get 4. All divided through by 2. So I'm going to get 4 plus or minus 4 root 1 plus 4, which is 5. All divided by 2. And so this simplifies to give 4, sorry, not 4, 2 plus or minus 2 root 5. Well, then where's the a going to be? A's got to be the positive one of this, right? So A's got to be at the point 2 plus 2 root 5 and a y coordinate of negative 4. Okay, so that's that. Okay, B. Find the acute angle between the tangent to the curve at A and the line y is equal to negative 4. Okay, so the tangent to the curve at A, let's kind of draw that on. I'll draw that on in green, I guess. It's like that, something like that. Okay, so that's the tangent to the curve at A. And we want to find this angle here, right, that angle there. So first we want to find the gradient of the tangent. And how are we going to do that? Well, we are going to substitute our value of x at A into dy dx. So our dy dx was 1 minus a half x. Okay, so let's just take that. So dy dx was equal to 1 minus a half x. And the value of x, so we're going to substitute in x is equal to, what was it? 2 plus 2 root 5. Okay. And, that's actually the same thing as 2 bracket 1 plus root 5, isn't it? So if we substitute that in, we're going to get y prime is equal to 1 minus a half times by 2, 1 plus root 5. Okay, so the half and the 2 are just going to cancel each other out. So gone, gone. So then we end up with 1 minus 1. 1 minus 1 minus root 5, which is minus root 5. Okay, now this is probably where you're going to get a little bit stuck. You want to just try to think about what the gradient here means, right? What does gradient mean? Well, we can draw a triangle to represent it, right? So if this is a length of 1 and this is a length of root 5, right? So this here is 1 and this here is root 5, right? So this was like our tangent line there. Then that is going to represent a gradient of negative root 5, isn't it, right? Because what does the gradient of negative root 5 actually mean? It means that for every one step I go across in x, I go down by root 5. Okay, so if the gradient of our tangent is negative root 5, it means that I can draw this triangle, I go across one step and I go down root 5. Now, we wanted to find this angle, didn't we? We want to find that angle there, theta. Well, how can we do that? Well, we can just use tan. So we now say to ourselves, okay, well, tan theta is equal to opposite, which is root 5, over adjacent, which is 1. And so therefore, theta is the tan inverse of root 5. And if I stick that into the calculator, I get 65.9 degrees. Okay, so I think that's our answer. And I hope that that's clear. If you find this helpful, by the way, please like and subscribe and do share with your friends. All right, here we are in question 11. So in this question, I is unit vector in the positive x direction, j is unit vector in the positive y direction, time is in seconds, distances are in meters. We've got the initial positions and velocities of two particles, A and B. And particle A starts from the origin and it moves with a constant speed of 10 meters per second in the direction of 60 degrees above the x-axis. Okay, part A, I want to find the exact values of the components of the velocity of particle A in the x direction and the y direction. Okay, what do we mean by those components? We mean this thing here and this thing here. Okay, so this is going to be the horizontal component of the velocity, and I'm going to label that, let's call it Vx. And this is going to be the vertical component of the velocity, which I'll call Vy. And hopefully you can see that this makes up a right angle triangle where the hypotenuse has got length 10, right? Because it's got a magnitude of 10. So we can use trigonometry on this, essentially. We can say that cosine of 60 degrees is going to be equal to the adjacent, which is Vx over the hypotenuse, which is 10. And we can say that sine of 60 degrees is going to equal to the opposite, which is Vy over the hypotenuse, which is 10. Therefore, what does that mean? It therefore means that Vx is going to equal to 10 times by cos 60. Well, cos 60 is a half, so 10 times by half is 5. And Vy is equal to 10 times by sine 60, and sine 60 is root 3 upon 2, so we get 5 root 3. Okay, so if we were to go over to here, we want to write out the velocity of A. We can say it's equal to 5I plus 5 root 3j. And I think it's better to write this as a column vector, so I'm going to write it as 5 root 3 like that. Okay, so that's part A done. Part B, find in terms of t the position vector of particle A at time t. Well, essentially, we need to know and understand this formula r, which is the position vector at any point of time, is equal to a plus vt, where a is the initial position vector and v is the velocity vector. Now, why is that? Well, let's imagine we draw it out. So here we've got the origin. Now, the origin is the point about which we define all of our vectors. It doesn't mean where the particle starts from, right? It just means where we're defining all our vectors from. And let's say that our particle does start from, let's say, over here, right? So that's our initial position where t is equal to 0. And it moves in a line like this. So it kind of moves like that, okay? All right, so how could we define a vector that takes us from the origin to any point along that line, right? So we're going to call that r, where r represents the position vector of any point along that line. Well, what would we need? Well, firstly, we would need to know the position vector of our initial position, which I'm going to call A. So that A is the vector that kind of defines our position at time t is equal to 0, where we start from. And we also need to know like what direction we're heading in, right? And the direction is the velocity vector, right? So velocity kind of tells us, it tells us how fast we're moving, but much more importantly than that, it kind of tells us where we're moving, right? In which direction. So imagine now that we're moving in this direction. So we're moving in this velocity, right? If we move 1 second, we'd be here. 2 seconds, we'd be there. 3 seconds, 4 seconds, 5 seconds. So if I want to find out where I am at any particular point in time, right? What I need to do is I need to have the initial position A plus the velocity scaled up by time, right? So v times by whatever t is. So if it was at 5 seconds, it'd be like A plus 1, 2, 3, 4, 5 steps of v, okay? And so that hopefully means you can understand this formula, right? A plus vt. Now, in the case of particle A, the initial position is the origin, right? So it's 0, 0. The velocity is what we got here, so it's 5 root 3. And the time is just t, right? So we know that we can write this as 5 root 3 times by t, okay? Okay, and then let's do part C. So particle B starts from the point 2 root 3, 9 at time t is equal to 0. It moves with a constant speed of 5 upon 3 parallel to the positive x-axis. Find in terms of t the position vector of particle B. Okay, well, it's actually just the same idea, right? So we want to find the position of particle B. So what's its initial position? Well, we are told in the question that it is 2 root 3, 9. 2 root 3, 9. What's its velocity? Well, we are told that it moves with a speed of 5 upon 3 in the x-axis direction. So in other words, its I component is 5 upon 3 and its J component is 0. Okay, so can you see that we've basically done the same thing, right? R is equal to A plus VT for particle A and then for particle B. Okay then, hence we want to show that these particles collide for part D. Well, if they collide, then what it means is that the position vector of A must be the same as the position vector of B, right? They've got to be at the same place at the same time. So how can we do that? Well, we can just try to solve some simultaneous equations. So 5 root 3 t must be equal to 2 root 3 9 root 3 like that, plus 5 upon 3 0 times t. Well, why don't we just take each line of this one at a time? So we can do the first line and we can do the second line. Right, so if I take the first line, then what am I going to get? I'm going to get 5t is equal to 2 root 3 plus 5 upon 3t. Okay, so we want to try to solve that to find out what t is. So I'm going to multiply everything through by 3. So I get 15t is equal to 6 root 3 plus 5t. So that means that 10t is equal to 6 root 3. And therefore, t is equal to 6 upon 10, which is 3 upon 5 root 3. Okay, well then I want to see if that value of time also satisfies the second one. So we're going to check against equation 2. So if I do that, then we've got 5 root 3t is equal to 9. And that means t is equal to 9 divided by 5 root 3. Okay, well, we're going to rationalize that. So we're going to times the top and bottom by root 3, root 3. So on the top, we're going to get 9 root 3. And on the bottom, root 3 times root 3 is 3, right? So we're going to get 5 times by 3. And we can cancel that to give 3 root 3 upon 5. And that is exactly the same as we got for the first line. So in other words, we know that when t is equal to 3 root 3 upon 5, RA will be equal to RB, and therefore A and B must collide, right? Because they've got the same position vector at the same time. Okay, so that's the core idea. Hope you find that helpful. All right, then the last question on this paper. A metal tank is in the shape of a cuboid with a square base of side x and an open top. The tank has a volume of 5 meters cubed. Given that x can vary and that the area of the metal used to make the tank is a minimum, find the dimensions of the tank. Okay, I think it's best thing to do is just draw this out. So we're going to have a square base. So let's say it kind of looks something like that. Okay. That. And it's got some unknown height, so kind of like this. Okay, and so this dimension is x, this dimension is x, and this is h. Okay, so we can write two formulas for this, can't we? We can say that the volume is equal to the area of the base, which is x squared times by h, and we know that that's equal to 5, so 5 is equal to x squared h. And we can also say that the surface area of this container, well, we got the area of the base, right, which is x squared, and we've got the areas of each of the faces here, right, this kind of rectangular face, and that's equal to x times by h, and we've got 4 of them, so it's plus 4xh. And we don't have the one on the top, right? So there's no x squared one here. Why? Because it's an open top. Okay, now we can rearrange this guy here to get h is equal to 5 upon x squared. And we can substitute that into the equation for the area so that we get the area is equal to x squared plus 4x times by 5 upon x squared, which is the same thing as x squared plus 20 upon x, or x to the power negative 1. Okay, so in other words, we want to try to get the equation so it's just in terms of x's. All right, now we know that the area of the metal used to make the tank is a minimum. So we want to find the minimum of this area. Well, how do we find the minimum of the area? Well, we find the stationary point, right? Which is going to be dA dx when that is equal to 0. Okay, so we're going to differentiate a, which will give us 2x minus 20x to the negative 2. And we will have a minimum value for that, minimum when dA dx is equal to 0. So we are trying to solve 0 is equal to 2x minus 20 upon x squared. Okay, so 20 upon x squared is equal to 2x. So we can write that as x cubed is equal to 10. So x is equal to the cube root of 10. Okay, and that is 2.15. Okay, so that's that. And what do we want to do? We want to find the dimensions, right? So we want to find h as well. So h is equal to 5 upon x squared. So h is equal to 5 upon the cube root of 10 all squared. And that guy is going to be equal to 1.08. Okay, so I think that's all the question is asking us to do. Yeah, find the dimensions of the tank. Okay, so essentially the key thing is, can you form these two equations here for the volume and for the area? Rearrange it so that the formula for the area has just got x. You want to differentiate it y because effectively we're just finding the stationary point. Okay, I hope that was helpful. And if you're finding these videos useful, please like and subscribe, and good luck with your exams.